Hello. So yes, I am not Sarah Williams. Sarah and I have worked together for about a year and a half. And in the spring of this calendar year, we taught a class called 11.458 Crowdsourced City. So let's get going. So this class was a graduate course, a mixture of architecture, urban planning, landscape architecture, and a few urbanism students. And the concept of the city was a prototyping workshop class or studio class based around civic technology, kind of investigating social media or other digital sensing platforms, and how to use those tools to enable advocacy. Critically, the class was not only about designing and sort of thinking about these tools, but implementing them and deploying them in a physical situation. That allowed the students to learn from the failures, to iterate, and to also bring these technologies into the real world where you can see kind of that fruit come to bear. So the four major objectives for the class were to develop a background in civic technology kind of as it is in the day, and then to work with a client to consider their needs. In our case, this year we were just working with MIT and looking at a site on the university campus. We did some basic programming skills in BASIC, JavaScript, and depending on what people wanted to do, a little bit of Python, a little SQL, a little C, and a little Go. And then we prototyped and deployed the technologies with the students. In our case, a few different sensing technologies. So this last step is critical to really deploy and make these technologies concrete, to really translate the ideas from the screen or the page into the real world. So the question we were trying to ask is, how can we measure the social impact of public spaces as it is essential to the public realm? And this is the topic that the lab, Civic Data Design Lab, has been exploring for a while, and the topic of the class. So one of these measurement processes is temporary or tactical urbanism. And before we move on, can I just get a quick show of hands who's familiar with tactical or temporary urbanism? Okay, so the big idea here is kind of pop-up interventions, sometimes radical, that transform city space. So the most common example is parking day, where you take a parking space and turn it into and activate it for public space, sometimes literally a park. These are really exciting because they provide a new character to the urban space. They change it, and then we can start to measure and understand it in a new way. And that's exactly this. It's not a new question. Planners, designers, and geographers have been asking for a long time, how do we understand the character of urban space, and especially when it's changing and dynamic? One of the theorists that we point back to in the class is Gehl, who's a really important architect and planner. His work focuses on the measurement of public space, how people use and occupy that space. He developed a few different techniques and tools to look at people moving through space and to justify changes to public space. William Whyte was another theorist that we look back to, who tried to systematize and kind of quantify the way in which space was used. One of his key findings was about modular movable furniture. So if you see a lone chair in a plaza or a college quad, there's a decent chance that he may have influenced that decision. So following that, we had students go out into our site and perform some of these methods, counting people, augmented with computer vision, and a few other techniques. We examined some existing technologies and toolkits, keeping in mind that we wanted our end results to be free and open source, that someone could pick up where we left off and do something else with it. We combined these with a design intervention, a physical intervention in the space. And the class designed, implemented, measured, and finally represented what happened in that space. So we did a few different workshops with sensing technologies. We did computer vision and machine learning, GPS tracking, infrared beams as counters, and a two-dimensional LiDAR, as well as Bluetooth and Wi-Fi sensing for triangulation in space. Lastly, we touched a little bit on environmental sensors, sound, air composition, et cetera. One of the other things we did was not only sensing, but feedback. So we did a workshop on Arduinos and microcontrollers about how you sit down on a chair and it gives you an LED showing that there's something being tracked, or similarly, day-night cycle. So as early as possible, we tried to get sensors out in the field. This is us playing with one of the LiDAR sensors, which is kind of two-dimensional. And we found that this was a fun tool we didn't end up using, but it works nicely with Raspberry Pis, which was our main platform for sensing. What did end up working well was Wi-Fi sensing. This is essentially a few Raspberry Pis that send out signals, look for Wi-Fi devices, and then kind of get that back together. We did a very brief geometry and math lesson, which is here, and then put together that all in a workshop. So here's the class together trying to see how accurate the triangulation, or more precisely triliteration, of these devices are. We also did some with our very high-tech solution for computer vision. Critically here, we had the students use an angle that was above, so there were no faces captured, but I would also put a plug-in for considering using infrared cameras instead of normal cameras, because then you just get sort of heat detection, and you use it in the same way, the same algorithms, but you avoid privacy issues in the same way. This is a rough overview of the software stack used for the machine learning. Used Anaconda as the distribution, Python 2.0, rest in peace. And then the Bbox labeling tool together with a few different computer vision libraries, in this case YOLO, which is you only look once. So without further ado, here's our site, the Samtec Lee building, building 9. This is just off Massachusetts Ave in Cambridge, if you've been. It's a great site because you have a lot of people going to it. It's a terrible site because it's just a big plaza with nothing on it. One of the prominent features of the site is these steps that lead up to the plaza, but they really divide it from the sidewalk, from where people park their bikes and walk by and so on. So this edge became a really central thing that students examined. What is that edge? How do you bridge the gap? So here's an overview of what the final design looked like. There were 10 movable cube seats, and then 8 stationary seats that were on the steps. Additionally, there was this kind of pixel blue pattern that was implemented onto the surface itself to try and break up the monotony. So here's what it's like. We tried to make it as green as possible. You can see on the back of these chairs, there are little planters, and it seemed to activate the space. Student seating solution really enabled people to sit on it and kind of use that space in a good way, and really encourage people to be there. Maybe. So here is a quick video that just shows the overview of the final design. We don't need sound. So this is a drone overview. We knew that there were a lot of necessary paths going through the space, in and out of the building, so we tried to make sure that there were no obstacles to people who had to take a certain path. But it really changed the way the space felt and the way you could activate the space. So on to the good stuff. So the main sensor, like I mentioned, is Wi-Fi sensing or Wi-Fi sniffing, if that's your thing. And students selected this because it's really flexible in how it detects. So the package architecture, we had Raspberry Pi, which was running Find 3, which is an open source scanner, unfortunately coded in Go. And those Raspberry Pis have an internal Wi-Fi sensor and Bluetooth sensor, as well as an external one that essentially broadcasts the signal. There's additionally a battery bank that allowed them to last most of the day. Here's what that looked like. So there's waterproof pouches with all this stuff sort of crammed inside. Originally, these were going to be put into the furniture themselves, but due to sensing issues, we ended up putting them in sort of these plastic planter pods. There were 5 of these packages located around the plaza, and together they sort of broadcast different detections to a single server that were then aggregated to a 1 meter by 1 meter grid. Additionally, there were Bluetooth beacons put into the movable benches to track those. These are essentially like, if you're familiar with like a tile or like an iBeacon, they do essentially the same thing as the Wi-Fi detection, but with Bluetooth. So here's an early attempt at what that software looks like. At first, we started with just doing raw signals, but then ended up doing sort of a least squared interpretation to get a more accurate approximation of the triliteration or triangulation. So then there was an API server that fed the visualization as well as our data archive, and here's what that looks like. Critically here, the MAC addresses were anonymized with IDs, but so each of these sensors kind of had its own signal strength and then approximated a location on our map. Here's what that looks like in JSON. And just to recap, so we had the raw data captured from different points that was then aggregated between the different sensors to kind of coordinate what the location probably was, and then aggregate it to a 1 meter grid and then visualize that data. Over the 5 days, we counted over 60,000 unique devices each day with about 3.8 million total signals detected. For the data visualization, we used Vega Lite, which is in the same vein as D3. We selected it because it's really good for streaming data, which was what we were into. And it was also, because this course also did not have any particular prerequisites, it was very friendly for some of the students to explore. On a technical note, it's also an imperative versus a declarative programming language, which can have some benefits if you're trying to get people thinking about CS in a different way. So there was real-time data on a screen located there. And this is what that looked like. So So over the course of the days, you had different data. In here, the blue is showing the furniture, and the red is showing people. And then here's what an overview of the 5 days looked like. So you can see a strong kind of angular tendency. Monday, we had a little bit of an issue because one of the sensors got moved. And so there was some data integrity issues. But all in all, this is what it looked like. And kind of there's a strong central tendency of people going from kind of where all the transit was located straight into the building. So a lot of these necessary trips were not something that we influenced with our furniture, but there was some more activation with some of the programming that happened. If you are interested in learning more, we have a quick visualization of it up at square9.mit.edu/viz, where you can explore each hour of each day as it unfolded. Thank you very much.
Any questions? Thank you for your talk. I like what you were saying about the infrared idea as sort of an obfuscation. I'm wondering what the ethics for us as practitioners are around potential future de-anonymization techniques, like X-modal ID with gate detection. Like, what's incumbent on us to do now to prepare for future advances in machine learning that could de-anonymize?
Yeah, it's a really important question. And actually, interestingly, in Cambridge, this project that we did, we would have had to, when we did it, it was okay, but now we would have had to get kind of municipal approval because this sort of surveillance is no longer unregulated. The gate detection is a really important question because even, like facial recognition is kind of a big scary thing right now, but that's where the aggregation, where the 1 meter grid, I think, comes in, looking at activity as a heat map rather than kind of specific paths. The advantage to having the pseudonymous IDs that we did is we can still do analytics on things like average, stay time or average passing time. The legislation is going to change based on where you are and kind of what's going on, but I think it's critical to do as much as you can while still being technically feasible and getting the kind of educational value across.
One more question? I sort of question your use of the term crowdsourced, which is, I guess, more traditionally voluntarily given up information or semi-voluntarily given up, maybe in more cases than that, as opposed to detected. So I was wondering if you could speak to that.
Yeah, so that's a very astute question. So the class historically has been more focused on crowdsourced solutions, web apps, and mobile apps. So yeah, this is more of a sensing direction, and we did do some efforts to kind of really signpost what was going on, and we had a public site that was describing kind of how are we using this data, what's going on, as well as how to opt out, which is you flick off Wi-Fi, which is not a free action, like there are consequences to it, but it is a way to opt out and you won't be sensed. So in terms of crowdsourcing in the future, I think thinking about what community we're engaging is maybe something to think about. Maybe in a less public space, I think the ethics are a little clearer, but it was a serious question. Yeah.
All right.
Okay.
Thanks.
Thanks, everyone.